Our last configuration is common gain. So this is a common drain configuration. So the input here is connected to the gate, and then the output here is connected to the source. So drain is the unused terminal. So this is a common drain. Okay, so let's say we consider this specification. Specification are given. The threshold voltage is 1 volt, and K is given as 1 milliampere over V square. The input impedance is already given. R1 parallel with R2 equal to 300K, and then RDS is infinity. So you can ignore the small RDS. IDQ is 1.7 milliampere. Okay, we start with the drawing of the equivalent circuit. Okay, we draw the equivalent circuit starting from the input, the signal. This is the VI here, and then we have the C1 is short circuit. Okay, so C1 is short circuit. So next is R1 and R2. R1 and R2 will become in parallel because the VDD is ground. So we have here, this is your R1, R2. Okay, so at the gate and the source, this is open circuit. This is open circuit. And then at the source, we have the RS. And then we also have the RL. At the drain, this is connected to the ground. Okay, so this is the AC equivalent circuit. When you see this AC equivalent circuit, the input impedance is seen from the input port. This is your ZI. So from this, based on this equivalent circuit, you only see R1 and R2. So RS, RL will not be considered because there is no physical connection between gate and source. This is open circuit. So the ZI is equal to R1 parallel with R2, and then it's also already given in the question, which is 300 kilo ohm. Okay, next is output impedance. Okay, let me redraw the circuit. So we have here, this is your VI, this is the R1, and then we have here the R2. At the gate, we have the VGS, and the source we have here, this is RS connected with the RL, GM-VGS is grounded. Okay, so the output impedance is the impedance seen from the output port. Okay, so the output impedance is equal to V out over I out when the VI is equal to 0. Okay, so this circuit actually can be redrawn into by considering the VI is equal to 0, and then by removing the RL. So when VI is equal to 0, R1 and R2 can be ignored because this is bypassed to the ground. So what left in the circuit This is the output. Okay. So this is what left in the circuit when you do the analysis for the output impedance. Okay. So the output impedance can be defined as the Z out equal to RS parallel with impedance denoted as a ZS. So RS parallel with the ZS. ZS stands for the impedance at the seen from the source terminal of the MOSFET. So this is the source terminal of the MOSFET. So ZS is equal to Vs over Is. Okay. So Is direction is toward the left hand side. So this is your Is. So this is the Vs. So what is Vs? Vs is equal to minus Vgs. And then what is Is? Is is equal to the opposite of GM-VGS. So minus GM-VGS. So this can be equal to 1 over GM. Okay, GM is okay, we haven't calculated the GM. So what is GM? GM is equal to 2KID. So the K is given as 1 milli and then ID is given as 1.7 milliampere. So the GM is equal to 2.61 millisiemens. So this is the GM value. So when you insert the value, the ZS will become 383 ohm. So the output impedance is RS parallel is 383. So RS is 1K. RS is not 1K. RS is 1.2K. RS is 1.2K parallel with 383. So this will give the answer 290. So this is the solution for the output impedance. Okay, next is voltage gain. So again, redraw the so this is VI, R1, this is your R2, okay, so this is the equivalent circuit. So AV is equal to V out over the V in. V out is voltage drop across the RL. So V out can be calculated by using the Ohm's law. The voltage drop at RS and RL they combine in parallel. So V out is equal to the current that pass through the RS and RL in parallel is GM-VGS. So this is GM, VGS, RS parallel with RL. So we insert the value. RS is 1.2K, RL is 1K, so this gives 1.42 VGS. So this is your V out. So what is V in? V in, the voltage at the input. This is the V in here. So the V in is equal to VGS plus V out. So V out is equal to 1.42 VGS. So this is VGS plus 1.42 VGS is equal to 2.42. VGS. Okay, at the end, AV can be solved as V out over the V in, 1.42 VGS over 2.42 VGS. This is 0.587. Okay, so this is the equation for the solution for the voltage gain. For the common drain, or sometimes we call it a source follower, so the voltage gain is usually less than 1. So the common drain will not act as a voltage amplifier, but rather this is used as a buffer application. Okay. What does buffer do? What is the function of the buffer? Buffer act as a matching circuit, impedance matching circuit. One of the requirement of the buffer is you need to have high impedance, high input impedance and low output impedance. Okay, if you see our analysis just now, the output impedance is quite small, 290 ohm, whereas the input impedance is 300 kilo ohm. So this is the characteristic of the common drain.